Hi everyone, we're just going to wait one more minute and we'll be starting with the webinar very shortly. Thank you everyone for joining. Okay, thank you everyone for joining our session today. As you all know, we have recently launched version 3 of Karamba, and in today we'll be showing you some of the new features and talking about how the new version of Karamba 3 works. During this webinar, feel free to ask us questions in the Q&A. We can either answer them directly in the chat or also at the end in a smaller session to discuss with everyone. We're very happy that everyone's joined us for this talk. Just to introduce the team who are talking today, I'm Matthew, and together I'm here with Clemens, as
Hello.
well as Georg.
Hi.
And we're all part of the Karamba team. So now I just want to start with the, this session will be recorded and also shared on our website later on. So let's jump onto the presentation. So as you all know, Karamba 3 version 3 has been released for currently for Rhino. The Mac is coming, we promise. So hopefully in a couple of weeks that will be released. So we'll be going through some of the new latest updates in the newest Karamba version. So you might have noticed if you've already installed Karamba, the new version, that the settings has now, or the settings component has been now removed. There is a toolbar where you can actually go in and adjust the settings of your Karamba definitions. You can also change the UI language. So at the moment you have the English, which is the default, and also Spanish, and we'll be releasing more languages to come as well. There have been some slight adaptations to the existing components, namely this new one called create linear element. So the line to beam and the index to beam and connectivity to beam has been consolidated into one component. With the line to truss drop-down menu, you can directly make a truss element as well. Similarly, there's a create surface element, which allows you to create a membrane, directly. And the assemble model has been simplified in a bit where there's additional drop-down for the options where you don't need to specifically put in any input if you do not need to. So the load combinations is one of the newest things that we've been working on very intensively for the last few years, let's say. And this allows you to now create load combinations in Karamba using the load cases that you've defined. So we have recently released a couple of videos on our tidbits that talk about this, but I'm just going to explain a little bit quickly about these components. So there's the load case combinator, which allows you to combine and create different load combinations out of your load cases. There's the load case combination settings, which allows you to set, for example, if this load case or load combination is undergoing a second order or first order theory analysis, and also specific settings for the calculation. And of course, for the results, you can actually use this load case selector to filter out all the different results, which then can be used and plugged into the model view, beam view, shell view, as well as all the various result components found in Karamba. So you can see at the moment, the output is always a text-based sort of string or object, which you can also write yourself to if you would like to, using the same sort of methods. Cross-section optimization, which Clemens will be explaining in a bit more detail. At the moment, now you can also, so previously we were always able to optimize as per utilization. Now you can also specify a load case or load combination for displacement optimization. And you can also filter out those specific element indexes, which you can plug in, for example, into the model view to filter out those elements which are overutilized or do not meet the displacement criteria. The reaction view is a component that Georg will also explain in detail. This allows you to preview the reaction forces and moments of your supports with different types of mapping here, as you can see as a preview here. So based on color, direction, and also upper ranges as well. And the SAF Explorer is something that we've also implemented. So this takes a simple Karamba model that you can then export into this SAF file format. So taking this Karamba model, we can simply export it. And then, for example, you can bring it into SEO or many other applications for you to then do your further analysis in FE programs. So SAF was introduced to us by Nathan Luke from Ideastatica, where they have also been testing very intensively the workflow from Karamba to Ideastatica. But this workflow allows you to integrate Karamba now much more fluidly into your current workflows. So a couple of sort of new and adapted features and utilities. This is a surface to truss component, which we've also released a short video about explaining on how you can use it. It simply takes a surface and you can create different types of trusses on it. And we've also adapted the line-line intersection component. So this allows you to actually put in curves that you want to intersect and curves to use for intersecting, and then also keeps the path structure to of those input curves. The manual is coming very soon. We're on it, and hopefully it will be released in the next very, very shortly. And as I mentioned, we are always releasing more and more tutorial videos on our website, on our YouTube and Vimeo channels. So stay up to date on those to see all these new features explained in these short tidbit sessions. And now I want to jump onto some live demo. So the first demo that I'm going to show is the load case combinations or load combinations. So generally, here we have created two types of load cases. We have the wind load case, which is a point load, and we have a beam load, which is named snow. The load case combinator component here allows us to create two different load combinations using a specific, let's say, mathematical formula. So the first one, I'm just using SLS equals snow plus wind. So you can basically use a plus or a minus to combine your different load cases. For UOS, you can see I've created a multiplier for snow, which is 1.35. And for the wind, I'm doing a or using this vertical line symbol to say that I either want minus 1.5 wind load in one direction and positive 1.5 in the other. And so if we look at the output for the load case combinations, we can see that we've created three actual load combinations. Two of them belong under this ULS. And this forward slash with the 0, 1, and the other indexes basically indicates how many load combinations of that type are available. So this is just plugged into directly the load component input for the assemble model. And now you can analyze for all your load cases and all your load combinations. At the moment, you might wonder why we have multiple models in the preview. And this is because at the moment on my load case selector component, I've selected ULS. And as we saw, we have two ULS load combinations, one for the positive and one for the negative. So OR shows you both, but I can select between one or the other to preview the different load combinations. If we go to OR, for example, we can actually select if we want to preview the minimum or the maximum value for all ULS combinations. And here you can also filter through all the subsequent different load cases or load combinations too. There's also, if there's multiple load combinations, you can then also filter them with the leading properties, for example, based on normal forces, bending moments, or if you were interested in looking at displacements or even the supports. So the output of our of this component can be plugged into the model view and the beam view, or for example, we can plug in the model output and plug this into any of our result components, as well as the load case input with this max or min or subsequent guide leading property as well. And this allows us then to filter out different results for different load cases, as you can see. So here I have the beam displacements, the reaction forces, and the utilization component there. So you can filter those results. Okay, that's it as a short introduction for the load case combinations. I will now forward the presentation to Clemens, who will talk to you about the optimization.
Thanks, Matthew. Let me just share my screen. Oh, where is it? I hope you see my screen now. This is a very simple example of a frame. Here it is. A frame which has, and here's the geometric setup. Very easy. Here it gets converted into, the lines get converted into beams to form the frame, which is fixed at the base points. And there are two loads applied to this frame. First of all, a point load, which symbolizes wind, for example. And in addition to this, there is a beam load, block load. This signifies snow. So there are two loads which act in different directions, the wind horizontally and the snow vertically downwards. And what I do now in the next step is to specify a serviceability limit state combination. I simply add snow and wind for that. So that's just a very simple load combination. And yeah, Matthew already explained to you how load combinations work now in Karamba. You can input here formulas or whatever. And of course, to make sense or to make this more useful, it has been also important to update the cross-section optimizer to make full use of these load case combinations, because the main point of application is to differentiate, or to be able to differentiate between the serviceability limit state and the ultimate limit state, because different safety factors apply depending on whether you optimize towards maximum displacement or collapse of the structure, of course. I mean, the former method of working only with characteristic loads and then limiting the utilization to 70% can still be done. So this was also one of our aims to not change the workflow of the past, but instead to take it and to add new features to it. And in case of the cross-section optimizer, there's now the option to have different load cases for the utilization and for the displacement optimization. You can set also different values, of course, for the two scenarios. And the major improvement here is now that this displacement optimizer is based on the principle of virtual forces. This means that the different parts of the structure which are too weak can be strengthened, but only in those regions which are actually too weak, and not as it was the case in the previous version of Karamba, that all the structure was made stronger or less strong. If I switch here now again to the image here, I would like to focus a little bit on the displacement control, because there are now some nice new features to it. Instead of only being able to supply a maximum allowable displacement, it's now also possible to supply a direction. So for example here, this is a x vector which is scaled by 1.25. And this means that the displacement optimization takes place in such a way that the maximum displacement in that direction is according to the length of this vector. I took the model and retrieved the nodal displacements from it. The frame is actually subdivided into multiple segments. So by taking those translational displacements, I get a good overall insight of the displacements. And here you can see now, first of all, I multiplied the displacements by a factor of 100. That's to go from meter to centimeter. And then I decompose the vector to get the x and, in this case, the c component. There's no y component because it's a frame in the x-c space. And here, this gives me now the maximum and minimum x displacements, and here the c displacements. So by changing here now this value, you see that it corresponds very well to what I prescribe. It's always on a little bit on the safe side, as you might notice. But that's not the only thing that's possible. I mean, if this is a little bit complicated, because if the vector is chosen in the wrong way, for example, in the minus x direction, then there would be no displacement control, simply because the whole frame only moves in the positive x direction. What I can also do is I can combine now different settings. So I can combine this displacement control in x direction with a displacement control in c direction, which I would like to have maybe to limit the vertical displacement here on the roof. So I can supply here a list of criteria like this. And now you see the c value is now also in accordance with my criteria. It's still possible to supply numbers. If I supply a number, then this limits the resultant displacement of a point. And one small thing still is this possibility here. It's also possible to supply a plane. You might wonder why or when this is useful. Think, for example, of having a floor slab, and you want to limit the horizontal displacement in the XY plane, for example. And then I can set up a corresponding plane in which I want to limit the resultant displacement. So for example, here in this case, it's the same as supplying here a limit in x direction. But for three-dimensional cases where there's a movement also in y direction, that makes sense. And so I can now also limit the displacements via this plane here. As I said, the whole thing is based on virtual work. So it's also possible to supply virtual load cases directly, which is, however, something that I would like to explain in a separate tidbit. The rest of the input plugs is very similar as compared to the old component. There's one thing which is new. It's now possible to visualize the elements which are insufficient. For this, I would like to switch to a different, here it is, to a different example. This here is an example of a cantilever shell. Here you can see there's the vertical downward load. It's fixed here. And when optimization of the thickness of the shell elements is done, you get this typical eye profile shaped cross-section. And since in shells there are always points with some kind of stress singularity, the design component tells me that there are 3 cross-sections which have reached their maximum cross-section size. And if you wonder now which those elements are, at the max util view output, I get now the shell index and the corresponding mesh face index. And if I plug this into the model view on the view, I get now those 3 elements which are overutilized. And if I change, for example, the maximum utilization, if I lower it, then of course more and more of those elements get potentially overutilized. And this is also, I think, a nice feature to see what's going on in the structure. Okay, that's it from my side. I would like to hand over to Georg.
Hi.
Hey.
So I will switch to my screen. I hope you can see it. So I've loaded a simple example from our website. You can download this definition. It just consists of some columns with massive girders and a floor slab on top of it. And as I said, this example file is available on our website until here. And here we have the new reaction view component, which lets you visualize reactions at the supports much more easily than before. And you can, first of all, you can switch between the forces in the different directions. For example, now we visualize in Z direction, in Y, or in X. But also you can visualize the moments. Also, you can change the vector display, the thickness of the vector, which can be neat, and you can set a value, an absolute value, which results should be ignored. So if I increase this, all will disappear, all reaction forces, because we have very low reactions. But if I change to the Z direction, you can see arrows disappearing, which lets you help find potentially overutilized or the highest reactions relatively quickly in your model. And also, if I set it to 0 again, you can, as you can see, we have positive and negative values, and with these checkboxes here, you can decide which you want to display. And if you don't select anything, nothing will show. And I turn this back. So then the next thing would be the display scales. You have the option to scale in a certain range. So now you can see the two sliders on top are grayed out. So only those two are active. And if I change that, the size of the arrows gets scaled so that the smallest arrow is 0.07 units large, and the largest is now 4 units, and you can change it down. So you can have better control over how you visualize the forces. Also, you can change to absolute scaling, where you have the upper two sliders available, which just scales the kilonewton value to the meter scale. So if I change this to 1 kilonewton would be 1 meter. So the largest arrow is 87 meters long, but we don't want that, so I change it back to, but they are all proportionally in the correct size. And also you can display or hide the annotations and also scale them. So that's for the display and for the reaction view. And the other feature I wanted to show is the SAF export, which is just a new component which lets you export to the structural analysis format, which is supported by multiple softwares like Matthew already mentioned, IDEA Statica, but also Skia. And the first two tabs here are SAF specific, where you can add additional descriptive information to your model. And those are Karamba or export specific, where you can set the length of the segments for a beam element or the maximum faces of a mesh that should be exported, because those files can get pretty heavy, and also other software you want to export to maybe does not support those many faces of a mesh. But if the mesh is a flat surface, no matter the orientation, it should export as a surface object. Also, you can set the SAF version, which is important because Gluval only supports, I think, version 1.5. And yeah, so I'm going to just hit the export button, and you see at the info a small trace log from the export, which tells you if there was an error or if everything went fine. So this looks good, and this will create a Excel file, and the default file path is on your desktop, where you have all the elements in a table like Excel file. And this, if we head over to SEER, you can import using the open from SAF model. I've already done this because this sometimes can take a while until Skia translated all the elements. If I center it, you can see all my elements are here, and also the surface load that was converted from our mesh load. And in Skia, you just can hit the calculate button. And then maybe I select just all. And then visualize or calculate the model in Skia or any other program that supports SAF. And yeah, that's it from my side. So I think I let Matthew talk again.
Thanks, Georg. So I'll jump back into the presentation, and we'll finish off the last part of our presentation So just a bit maybe update on our licensing. As you probably might aware of, so we still have the free licensing options, the professional, the educational, and the lab license. The professional licenses are offered as annual licenses now, but that we also are offering a single month license. For those who have a current unlimited pro license from 2019 or earlier, we are offering also a discounted rate for those who upgrade. So please get in touch with us should you want to upgrade to the new version. And we also have a auto renewal licensing mechanism available so that we do not have to process payment manually anymore. So get in touch with us about this. So just to finish off our presentation for today, I just want to just give you also a preview of what we are currently working on and what we will be releasing, let's say, in the next year or so. You might have seen us being quite active with Speckle. This is a development that Georg has been working on quite extensively, and we hope to be releasing this very, very soon. So there is a Speckle connector that allows you to convert your Karamba model into a native Speckle structural model, which you can see here. And this allows you, for example, to then import it in such programs such as eTabs, SAP 2000, and also Revit and other programs for further analysis or documentation as well. We are also currently working on how to embed, for example, not just the structural axis that you see here, but also the meshes or other information into the Speckle model so that you can also visualize the actual cross sections in the Speckle viewer as well. So look out in the next week or so, we'll be releasing a work in progress version. All of our ongoing development is available on our nightly builds on our GitHub page. Also, if you have any bug requests or bugs or feature requests, please feel free to post them there. We will be uploading all our work in progress versions there as well. And so just a little about the future roadmap. We are currently actively working on a native concrete and timber design, let's say for the optimization as well as for the utilization calculations. Asynchronous components will be also made available very soon. We are currently working on a new measure that allows you to have much more control of the meshing of your surfaces and your poly surfaces. We all know meshing is a big issue in FE, so it's hopefully will help us to create much better calculation models. The Karamba version for Grasshopper 2 is also in development for those of you who have been looking at Grasshopper 2. And there is also a toolkit available for BOM. So feel free to check it out on the GitHub page as well. Just also lastly to end with just a couple of events where we'll be doing some workshops. Me and Clemens will be at the Design Modeling Symposium together with some with Speckle and some colleagues at Bollinger Grohmann to present a workshop, as well as at the ISS in Zurich, where we'll be doing a one-day workshop, also working with Speckle too. And lastly, we just want to ask you for the, let's say, last 20 minutes of this session, what would you like to see in future developments? And do you have any specific questions that you might want to raise? And I believe there were a couple of questions already. So with that, I would like to end our presentation. And let's look at some of the questions that are available. if there's anyone who also would like to.
I think I can go through some of the questions. Huh?
Yes.
There's one question from Rhino supports quad mesh. Is there any plan for Karamba3D to support quad mesh? Well, at the moment, Karamba is based on triangular shell elements, and they work quite efficiently. The question is whether to introduce also quad elements. Probably not in the next year, but this Rhino quad mesh tool is very useful nevertheless, because once you have a quad mesh, you can very easily subdivide it to triangular meshes. So that's why I would say that there's by default a support of this quad remesher, which is very nice because it can follow out details of the surface and so on. So yeah. Then can you share lists of softwares which can be exported from Karamba3D? Yes, there is a list, I think, available at SAF, for example. I mean, at the moment, we have several export options. One is via the DASTV file, which is a step format, which can be read, for example, by Global Airfam and Robot. Then SAF, which is now supported by very many Find Element software packages. Matthew, do you happen to know where the link is to this? Because they have a special website where they list all the. Here it is. Yeah, I mean the grade of how much of the SAF language those packages understand and support is different. Of course, Skia is probably at the moment the best to import and export SAF, but we have tested it with Global and it also works quite fine. Sometimes force or loads cannot be, or not all types of load can be exported via to Global, for example. And this is also probably true for some other softwares, but on the whole, it works really very well. And especially for flat surfaces with holes and so on, they come to SAF in a very clear and clean way. Then, is pre-stressing possible in Karamba? Yes, it is. I mean, there is a load. There's a load type which is called pre-strain. So you can pre-strain elements and thereby introduce post-tensioning of elements. And it's also possible to impose prescribed displacements on supports. So this could also be used to pre-stress structures. And since Karamba is based on a linear elastic material, mainly at the moment, pre-stressing doesn't change the stiffness as it would in reality for reinforced concrete, for example, because you avoid cracking. But for cables, for example, it makes sense to pre-stress them. I hope this answered the questions. Okay, then let's see. There's another. I have two queries. Is there a plan to introduce physical member modeling where it's not necessary to split beam at intersections? Yes, this is planned, because this would be such a great feature to be able to input any kind of curve or curve which is made up of different segments, and then to automatically be able to place a load somewhere on it or to query results and to also connect to it. This is something which I will definitely be working in the next month. So this is one thing which is high on the priority list. Mesh load creates one-way loads. Can we expect a feature that does something similar for two-way load distribution as well? In fact, the mesh load component it's not aware of directionality. It simply takes the loads which have been generated for the mesh vertices and places them on the nearest support or nearest structure point in Karamba. And in case of nodes, you get a nodal load, or in case of beams, a uniform distributed load is currently created. This is also something which will likely change, because now it's very easily possible to place arbitrary line loads on beams. So this then will also make it feasible to have not only a uniform load distribution from the mesh load on the beams, but a more precise one. I hope this answered the question. And by the way, this is also something which is a little bit of a problem in SAF, because in SAF, SAF differentiates between these load surfaces for shells and for beams, which is not the case in Karamba. But there will be, sorry, there will be a corresponding paragraph in the manual. Yeah.
There's more
I think the
questions,
next,
Clemens.
yeah, I think the next question would be, when will the Analyze NL VIP cease to be a work in progress?
Yeah, for this, I would have to reserve some weeks to clean up the code and to increase the convergence rate of this nonlinear calculation. But before this, there are things like, yeah, this, for example, beam connectivity, I think, or earthquake loads, which is also something which needs to be done. So maybe for trusses and membranes, that it will be shifted from work in progress to finished, because for membranes and trusses it would be really helpful, and it's probably not so much work to achieve a stable algorithm there. So it's hard to say, of course, always, but yeah, it's also something which would be really good and helpful, especially for membranes, of course. Okay. Is there a difference between using line to beam with bending set to false and using line to truss? No, there's no difference. It's a matter of convenience, because many people were not aware that we have truss, or actually rope elements. And so this option of changing this bending input was a little bit hidden, and so that's why we made it a little bit more obvious of how to create truss elements. But yeah, there's no difference.
Then I think the next would be, do you plan to integrate more type of structural analysis, such as seismic analysis?
Yes, definitely. Because what we have now as for the load combinations, we have load case combination. So really each combination is one load case. The next step will be to have result combinations, and that's then the feature which enables then also seismic analysis via spectral methods, for example. So this is also something which will come soon. Yeah.
Okay. Is there an increase in global performance in the new version? The second question would be, what are the minimal hardware requirements?
Yeah, there are some improvements. So the C++ core is now definitely faster than in the version 2. It's well, the recommended hardware at the moment is a CPU which has a large cache memory, L1 to L3 cache, because at the moment the calculations in Karamba, they are of course multi-core calculations, but nowadays the CPUs have so many cores that the link to the memory has become more and more the bottleneck. So if you want to have high performance with Karamba models or any finite element models, make sure to have a CPU with a large cache, because this improves the movement of memory to the CPU. And this is also something which is to be done in the next weeks or so to further improve this memory efficiency. So because, for example, for the now new Intel, what's it called, Intel 9 processors, they have so many cores now that it's that this memory movement is now very important and will be improved also in the future. And then, of course, these async components will also not make the calculation faster, but make the handling of large definitions easier and more comfortable, because once we have these async components in place, they will not lock the UI thread anymore. So it will then be easier to stop calculations and to make adjustments during the calculation. Okay, that's the answer.
Then the question from Juven Lu: is there a way to optimize cross-section based on buckling, global buckling factors?
Based on global buckling factors, not yet at the moment. That's also something which would be possible with a slight adaptation of the current algorithm. But at the moment, the procedure is like this, that one can apply imperfections, and if you apply these imperfections similar as how the buckling modes are, then these imperfections cause bending moments, and by this you get also a increased cross-section from this. But that's of course only an indirect way of dealing with this. Would be really interesting to be able to directly use these buckling modes for cross-section optimization, of course. Let's see. Yeah.
Okay, next question would be: will there an export to strand 7?
This one, I believe there is a geometry gym component that allows you to export to strand 7, if I'm not correct. But we will get into touch with John Merchant about this and see if he will update the exporter for strand 7. But there is no native exporter currently.
Okay. The next is: any development in hybrid construction, dimensioning of timber composite slabs, for example?
Yeah, a colleague of ours, she's currently working on composite cross sections, with an emphasis at the moment on reinforced concrete. But it will then be also possible to specify beam cross sections, which are composed of different cross sections with different materials. And yeah, let's see, for shells. Of course, it would be super to have composite cross sections for shells. Let's see. Yeah, it's certainly planned, but it's always a matter also of strategy to see which features are the most important ones. And of course, for timber construction, it would be really nice to have this kind of layered shell cross sections to be able to improve the analysis capabilities in this area. Let's see. Yeah, there are many features which would be nice, but only a limited amount of time. That's the thing, and it's a tough decision. Yeah, what to prioritize, and so that's why also we are always happy if you send us feature requests to see what might be interesting for you, and then to base our decisions on this.
Okay, the next question would be regarding the cross-section optimizer. Does it work for every load combination separately, or does it combine the individual optimization into a final one?
No, it deals with each load case or load case combination individual. Also, since the load case combinations are set up of load cases, so each load case is treated. Is treated, and the resultant cross section is then the cross section which satisfies the criteria for all the load cases. Yeah. So if you have thousands of load cases, of course, because it's easy to create those thousands of load cases, then it will of course be time consuming to compute them. Then with the next step, so to say, with result combinations, then this will alleviate this problem a little bit. But I mean, yeah, that's something which is computationally very demanding.
But I think one tip maybe we'll explain in a tidbits is to, rather than optimizing for every load case or load case combination in the optimization, to just say a governing load combination, and then in the analysis after the optimization to analyze every separate load case or load case combination. So you don't have to optimize for every load case in your model too. But this will be this can be explained in a shorter video to show the process a bit.
Yeah, and regarding handling large amounts of load cases, it's now possible in the analysis component, for example, to limit the analysis to only some load combinations which are important, and not to calculate all of them, because sometimes you can make an informed choice, and this then, of course, simplifies and speeds up the calculation.
Okay, I think, yeah, that answers.
That's it.
No, we have 3 last questions, I think, and then
Okay.
we say we close the door. What do you say?
Yes. Yeah, there's 3 questions. Yeah.
Okay. Any developments related to tuning curve-shaped building structures as per wind CFD simulation?
Okay, CFD calculations. Yeah, I mean, we actually did some experiments using OpenFOAM, which was mainly done by Georg, in fact. Maybe you can talk a little bit about your experiences, but I think it worked basically. But it's of course computationally very demanding, this whole CFD analysis. But I think there's even a tidbit video or an example somewhere. Georg, do you know?
There's a video on YouTube explaining for a simple cube how to set up CFD analysis with Butterfly. But the problem is Butterfly itself is not that, I don't know how I would say it, straightforward, or it's time consuming to set up the model and then always recalculate it, and then you have to not recalculate, but distribute the loads correctly onto your geometry. And yeah, I think there would be a more easy way would be nicer to have somehow. But
yeah, maybe ask ChatGPT something like this. Yeah, but this is actually something that we try to simplify this user interface, especially for the loads, because this is something which makes it very complicated for architects to deal with structures, to set up these loads. So yeah, maybe.
But it works. It works in Grasshopper with Butterfly if you are able to set up the model correctly.
Yeah.
Also Butterfly and the Karamba model. So yeah, they have to work together somehow. I think the next question is, I opened a model made in version 2 with version 3 and noticed that the path of the results has been shifted. Is this a known issue?
Well, actually not, because we normally keep an eye on being backwards compatible. So if we introduce a new component, the old one goes into obsolete and should work as before. Maybe we did some mistake at some components, it would be then helpful to have part of the definition to see which component is the culprit. But usually it should all be backward compatible. So if you experience any problems with regards to this, please send us a definition and an email. Then I can have a look why that happened.
Mm-hmm.
And this applies to the main versions, which we officially published. There have been some in-between versions which might have had problems regarding this, but from the main versions, they should be compatible. Yeah. Okay.
Okay. The next would just be, could you please give some comments regarding development of timber calculations?
Yeah, I mean, at the moment, there's this very useful plugin Beaver, which can do timber design based on Karamba results. But we would, of course, like to have this as a tool inside Karamba, especially because for wood, it's important to have a good load case management because of all these different safety factors which are differentiated with respect to the load cases. So that's something which is under development. So after having reinforced concrete cross sections and corresponding design procedures, we will then definitely also go on to develop something for wood, beams and plates. Okay.
Okay.
Last question.
Two questions came in right now. So I think that's the final two, and then that's good. So the first would be a question regarding load case combinations. Is it possible to automatically create envelope type combinations through the syntax?
The envelope, let's put it that way. The syntax does the load case or sets up the load case combinations. So we have OR, and then there's an operator where you can do this round, also the leading load combination and so on. But having this set up, you can then choose an envelope, for example, via either this load case combination selector, via this min and max options. You might have seen it in Matthew's presentation, but in the model view component and in this load case selector, it's both in both components. It's possible to select maximum, minimum, and then you get automatically the envelope of those properties that you visualize, so displacements, internal forces, and so on. And with the load case selector, it's also possible to specify the leading property. So, for example, if you want to know the largest normal force or the largest compressive force in the column, and those bending moments which accompany this extreme normal force, then you can also generate a selection for this. So selecting leading response properties. That goes also for support reactions, displacements, forces, and so on. So this selector component is quite mighty, but also a little bit complicated. Let's see. Okay.
Okay, and for the very last question, are there any developments in fire analysis like Saphir, or where you can simulate the behavior of a steel beam or a concrete slab?
At the moment, no, I would say. Well, that's, I would say, a matter of strategy. Fire design is something which normally comes a little bit later in the design stage, and you can handle it in different ways, not necessarily structural. So maybe there will be a corresponding option in the timber design module, for example. That would make sense. But for steel, I mean, you have the options to paint it or to enclose it with gypsum board or something like this. So for wood, it is, and maybe we can manage to include it in the design procedures for timber. Yeah. Okay, that's it.
That's it.
Thank you very much for your attention. Yes, thank you for, and also thank you for your continual feedback via email and via the McNeil forum. This is so important for us because to see that the software gets used and also what you would like to see or bugs, also very important to give us feedback with regards to what works and what doesn't work. Yeah. So thank you for that. Matthew, any last words from your side, Georg?
No, I just want to say thank you everyone for attending. I think there might have been some questions I noticed in the chat that we missed, but maybe we will post this on our discussion forums. And also feel free to post all your questions and queries on our discussion forum so that we can also try to address them as well. That's it from my side. And yes, thank you very much and hope to see you all very soon and have fun experimenting with the new features in version 3.
Bye-bye.
See you all.
Thank you.
Have a nice day.
See you.